In this video tutorial, I will show how to choose the machine learning model. As always, we need to solve real-world business problems. Machine learning is just a tool that we can use. We can use this tutorial as a separate one, but we can use this as a part of the larger picture, the machine learning workflow. And in this case, I will be describing the second point, the model, choose ML model. Before we can even start to choosing the machine learning model, we need to know what kind of models do we have and what kind of types of machine learning we have. In here, I grouped types of machine learning, the most common used, and we have supervised learning, unsupervised learning. So the supervised learning from labeled data to predict an output based on the input. So an example is image classification, spam detection, or sentiment analysis. In short, is just we have data that we know what kind of the data do we have, and we put new data and want to predict the output. In unsupervised learning, we are learning from unlabeled data to discover hidden patterns or structures. And we have example of applications, clustering, anomaly detection, market segmentation. In here, we have some input data, but we don't know what kind of data do we have or what is it. So the model needs to discover the hidden pattern. So the other types of machine learning are transfer learning, reinforcement learning, semi-supervised learning, and active learning. Now I will just focus on supervised and unsupervised learning algorithms, and we can divide them in classification, regression, clustering, and dimensionality reduction, and some algorithms for each of them. I know what you are thinking. So many types of machine learning, so many types of algorithms, the implementations. I could even show you more tables with more rows and with more descriptions, but fortunately there is another way. So the first way how we can tackle this task is just to see the choosing the right estimator diagram prepared by scikit-learn. And in here we have a starting point and we go if we have more than 50 samples. No, we need more data. If we have more than 50 samples, do we want to predict category? And going on the left, we have classification algorithms. Going on the right, regression. We have clustering and dimensionality reduction is very helpful. If we choose one of these algorithms, for example, lasso, we click on it. We are going to the page where it's described with mathematical formulas and the code. The previous diagram was for more technical people. In here, we have a different approach. We have a question, what do you want to do? And we can extract information from the text, predict between several categories, predict value, generate recommendation, or do the classification of images. So let's go and try extract information from text. We need to do text analysis, and what it do derives high quality information from the text, and it answers the question like what info is in this text and the algorithms for them, for example, word to vector. If we want to predict, for example, if a person will have heart disease or not, we will choose predict between two categories. And in here we have a classification and answers the question, is it A or B? We can, for example, choose logistic regression for it. For example, in cybersecurity, if we want to find unusual occurrences, answer the question, is it weird? So we can use anomaly detection. If we want to predict house price, we will use regression. If we want to do the market classification for our customers. We will do the discover structure, the clustering, and for example, unsupervised learning k-means. Now we know what types of machine learning we have. We know some of the machine learning algorithms. Now it's time to know what the machine learning model is. In high level of abstraction, machine learning model is simply mathematical formulas encapsulated in some code, for example, a Python class. And the machine learning model is a function that maps input features to output predictions based on learned patterns from the data. And there are important common parts for each machine learning model. It's a mathematical representation, functions, equations, probabilities, or optimization techniques. The training process, adjusting parameters to minimize error, and evaluation and inference, making predictions on new data. Have a quick look on the example, the linear regression model. It follows the equation y equals w times x plus b. And each of the components, y is the predicted output, x is the feature input, w is the weight coefficient, b is the bias intercept. So now we know what is machine learning model, and we know that it encapsulates mathematical formulas. How about seeing how it could be implemented, for example, in Python for a linear regression? And here's a scratch-built implementation of linear regression algorithm using only NumPy without any external libraries like scikit-learn. So the implementation includes mathematical foundation using the equation y equals w times x plus b, gradient descent to learn w and b, training, adjusting weights based on loss, prediction, making predictions on a new data. So as we can see, there is just a single import for a NumPy. There is a linear regression scratch class, and it has fit and predict method. It initializes the weights and biases, doing the gradient descent, compute predictions, compute gradients, update weights and biases, and of course predicts. Here is an example usage. So we generate some random data. We train the model, predict new data, and print the predictions. So, and how it works, it's divided into 3 steps: initialization, training, and prediction. In the first step, we start with random weights, W and bias B, both initialized to 0, training gradient descent, compute predictions, compute gradients, updates W and B using gradient descent, predictions. Once trained, the model predicts new values using the equation y equals w times x plus b, and that's it. We refer to machine learning model as an estimator. The machine learning model is a general concept, and the estimator is an implementation of a model. In popular libraries for machine learning, like scikit-learn, TensorFlow, Keras, and PyTorch, models are estimators. What is an estimator? An estimator is an object in machine learning that can be trained on the data and make predictions. And the estimator typically implements the following methods: fit, learns from the data, predict, makes prediction, score, evaluates performance. Let's go to an example of logistic regression for classification, and we can see the simple mathematical formula for it, where the left side of the equation py is the probability that y equals 1 for a given x. X is the input feature, w is the weight coefficient, b is the bias intercept, e is the Euler's number. The previous examples were from the classical machine learning, and for the deep learning neural networks, we use machine learning models as well, but they use multiple layers of weights and activation functions. So in here we can see the mathematical formula y equals f by wx plus b, where y is the output, w is the weight matrix, x is the input, b is the bias vector, f is the activation function. A simple neural network consists of an input layer, one or more hidden layers, and the output layer. Each layer has neurons nodes that apply weights, biases, and activation functions to the input to produce an output. The general structure is as follows. Input layer takes in the future input data. Hidden layers processes the data using weights, biases, and activation functions. Output layer produces the final predictions or classification. So let's do the coding. So all the mathematical formulas are now in Python classes. All we just need to do is use the right library and import the right class. So if you want to use this linear regression model, we need some machine learning libraries. The most popular are scikit-learn, TensorFlow, Keras, and PyTorch. So let's start with the simplest example using scikit-learn. So I have a code, estimator, and in here we will be using all I just need to do is import the library from sklearn model import. I won't be running this code. And I will create an instance of estimator. Okay, so now let's do the same for TensorFlow Keras. And estimator. I will be using sequential model. Just to make it shorter, I will just paste the code. So we have sequential, dense, so we have all what we need. And the last example of model usage I will show by PyTorch. Estimator. And I will be using simple neural network. And like in the previous example, import now torch and import torch nn as nn, and I will create an instance of an estimator model by torch nn dot linear 1 1, and in here we have single layer linear model. Okay, so that's it for today. So happy learning and happy coding.